This vehicle has no third brake light. In this video, we'll show you the first few diagnostic steps using a multimeter. The first thing we need to do is to set up our meter and place our meter leads in the correct jacks. So how we're going to do that is to first take our black lead and insert it into our common jack, and then we're going to take our red lead and insert it into the volt-ohm diode check jack. Now all we have to do is turn our meter dial to DC volts, which has the long line with the dotted line underneath. Now we're ready to begin.
Now we can attach our leads. We'll attach the red lead to the positive battery cable and the negative lead to the negative battery cable. And we want to make sure that we have more than 12.6 volts. Next, we're going to check the fuses, and all we need to do is use a test light. We're going to attach this side of the test light, the alligator clip side, to battery ground. Then the other side, as soon as it touches positive, it'll light up. And as long as both sides of the fuse light up, then we're in good shape. Opposed to a good fuse, which lights up evenly on both sides, a bad fuse will only light up on one side, but not the other. So if there were any question about whether a fuse, a wire, a switch, a component, or any other portion of the electrical system had excessive resistance or an open or break somewhere, then we could do a resistance test. So to check resistance, we leave our black lead in the common jack, we leave our red lead in the volt-ohm diode check jack, just like as if we were measuring volts. The big difference here is that we have to ensure that our circuit, when we're measuring ohms, is disconnected and not on. Okay? So we simply turn our dial to the horseshoe. That shows us ohms. And we take our two leads and put them on either side of the fuse. This one, as you can see, has a clear path for the electricity to flow through all the way through the fuse. But on this one that's open, it flows through the terminal, but there's nothing in between to allow the electricity to flow and out through the other side. And that's why the fuse lights on one side, but not the other. All the fuses here in the luggage compartment and on the passenger side kick panel appear to be okay.
Two wires that are securely attached together are said to have continuity. Now the meter measures continuity by flowing electricity from the red lead all the way through whatever you're measuring to the black lead. And if we disconnect it, then we see that the meter reads OL, which is open loop. So the electricity cannot get from one side over to the other side, or one meter lead to the other meter lead. That's why we see OL, which is open loop, also known as infinite resistance, because the electricity cannot jump that gap to get to the other side. It's just too much effort. Now we're going to take a look at a window switch, which will either pull the window up or down. Now, in order to test this, we need to use our multimeter on our ohms function to see if it has good continuity at the correct time. So we can just use our alligator clip on our meter lead and our other standard meter lead for the black lead, and we're going to touch the two terminals that correspond together to allow the window to go down. So now we just pull this switch down and we see we have continuity. When you release, you should not have continuity. So this switch is good.
We know that we have a problem that is very specific to just the third brake light. For example, the wiring. So what we're going to do is disconnect this third brake light. And we're going to use a few basic functions on our meter to let us know if we have a problem on either the power side, so this white wire here, or the ground side, which is this black wire here. First thing we're going to do to check these wires is to see if we have power and ground here at the connector. If we do have power and ground here at the connector, then the only thing that could be bad is the actual third brake light assembly itself. And you can see it has a little printed circuit board in there. Okay. So how we do this is basically use our meter, turn this to the DC volt setting, and carefully with our meter leads, now we don't want to jab these in, okay, but with our meter leads, we're just going to use the red lead on the white wire, which I've positioned here on the right side, and the black lead on the ground side. Takes a little practice to get this right. It's kind of like chopsticks. Okay, now the brake pedal is depressed and I have my meter leads attached to the connector, and we do not have any voltage. So that means that we have a problem on this circuit either on the power side or on the ground side. So now we need to determine which side has the problem. Okay? And we can do that very easily by first checking power. We just have a tendency to do that. Usually most of the problems are located on the power side because you typically have a fuse in line, a switch like the brake pedal position switch. In this case we know that's not it because the other brake lights work, or even a module. So I have attached the long jumper wire to the battery negative cable. So this gives me a good solid ground to again measure open circuit voltage. So I'll take my black lead, connect that to ground. Okay. Using my nice long jumper wire here. I'll just set that aside. Okay. And now, make sure I have the correct wire. I'm going to go ahead and check to see if we have power. Again, brake pedal still needs to be depressed, circuit needs to be active, and we do not have any voltage. Okay, so now what we want to do is check the ground side to see if we have a good ground. Now there's one of two ways you can do that. One way is to just simply check the resistance to ground. I've already looked at the schematic, so I know that this wire goes directly to ground. It does not go through any switch. So this should be hooked up directly to the body, and we should have good continuity to ground, meaning we shouldn't have any resistance to electrical flow to ground. So if we don't have a lot of resistance, then we shouldn't have very much, too many ohms that show up here. So here we have 4.4 ohms. It's not fantastic. I mean, really, we would like less than 1, but that's okay. I mean, it's definitely, there is some continuity. So for the next test, what we want to do is we want to check for a short to ground. Sometimes the power can be lost because the wire is directly connected to the ground side somewhere else in the circuit. So for example, if we had a short to ground here, then that's like these two wires being stripped of all its insulation, being connected together, and therefore electricity is not going to bother flowing through the bulb anymore, or even all the way to this connector. It's just going to go up to wherever the short is and then go right back to the battery. So what we can do is we can actually measure resistance. Now again, the brake pedal is still depressed, so if we have a short anywhere in the system, we should be able to see it. So we're going to use our ohms function again, and we're just going to check the continuity between the ground side and the power side. Now we should not have any continuity. or we should also see a very high resistance, somewhere in the kilo-ohm range, if we do not have a short, if these two wires are separated. And we should see a very high resistance in the kilo-ohm range if we are dealing with potentially an electronic circuit. But in this case, we have a reading of OL, which is good, which means open loop, which means that this power wire and this ground wire are not connected somewhere that they should not be connected. Okay? All right. So another test that we can do, just to verify that the ground is good, because we did see that 4.4 ohms there, is basically do an available voltage test, but in reverse. So instead of being hooked up to the ground on the battery, I'm now hooked up to the power side on the battery. And if this is a good ground, then I should see a voltage that is close to battery voltage. So I'll hook up my red lead to power, my black lead to ground. Okay, black lead, all right. And we get 11.96 volts. Now unfortunately our battery is at only 12.05 volts because it's been worn down, it's been on for too long. But this is close to battery voltage, so I feel safe saying that this is a good ground and that we have an issue on the power side circuit.